In this video lecture, we look at the very broad topic of solving equations. Now, I'm not going to be very specific here because you're going to get different types of equations, linear, quadratic, cubic, trigonometric, and so on. I'm just going to leave it very broadly, simply because it's a very brief revision of what you have done at school. So firstly, in the solution of equations, and here are examples of our equations. 2x minus 8 equal to 4, x squared minus 2x minus 3 equal to 0, and so on, with the variable x. So any equation, and we're looking at equations, have, of course, the equal to sign with variables introduced, and the main variable, of course, is x equal to, let's say, 5. So that in itself is an equation. But there is very specified. We already know that x is, in fact, 5 and nothing else. However, in most cases, we have algebraic manipulation that we have to maneuver through in order to get to a stage where we can directly say what x is and to check whether it is an answer of the given equation. So before we get to actual examples, what are the different equation types that we come across? Well, the first is when we get unique solutions. What do I mean by unique solutions? Equations that generate a finite number of solutions. What do I mean by that? So you could get an equation, for example, in A. Let's take A over there, which is 2x minus 8 equal to 4. I'm not going to go to the process of how we transpose and why we transpose. That originated at the beginning in grade 8, where you add or subtract whatever you do on the left-hand side, you do on the right-hand side. If you divide on the left-hand side, you divide on the right-hand side. But after a while, when you get to grade 9, 10, 11, and 12, you basically forgot that. And I'm pretty sure by now you forgot that because you just go through a process. For example, in this case, you transpose the 8, the minus 8 becomes the plus 8. You add that to a 4, you get 2x is equal to 8 plus 4. Then you divide and you get x is equal to 6. And then, of course, you can check this answer. You can substitute back into the original equation. 2 times 6 is 12. 12 minus 8 gives you the 4. But now notice that here's only one solution, only one answer. So there's a definite, there's a finite number of solutions in this equation. For B, x squared minus 2x minus 3, x squared minus 2x minus 3 equal to 0. That you identify as a quadratic. You get x minus 3, x plus 1 is equal to 0. Then you're going to say x minus 3 equal to 0. Or x plus 1 is equal to 0. You're going to get your two answers, x equal to 3, x equal to minus 1. Now that is a process that you've completed time and time again. We could double check that. 3 by substituting the original equation. If I take the 3, put in x squared and x, 9 minus 6 minus 3, that gives me 0, and likewise with minus 1. But again, there's only two solutions here. So there's a definite number of solutions. There's a finite number of solutions. And that in most cases, what really happens in many of your solutions when you solve in equations, you find that you get solutions. But then you also get the case, for example, where there's no solution. Let's look at this example. Solve for x if x plus 2 is equal to x plus 1. Now, knowing students and having taught many years in high school as well, you get to a process and then what do people do? Oh, transpose the x's, transpose the ones. And when they transpose the x, what do they get? 0 equal to -1. Whoa, wait a minute. Is that true? Absolutely not. So do you analyze from that, from this, that there is no solution? Well, you could possibly, but I would say a more in-depth analysis of that equation is necessary. Think about this very carefully. And this is the deeper type of understanding that is expected at university level. Not just a process or a procedure. But let's look at this here. Remember, x is any number, and whatever you decide to take for x, you must put it on both sides of the equation. So think of any number that when you substitute to the left-hand side and the right-hand side of this equation at the same time, whether they generate a true statement. Let's say you take 5. On the left-hand side, you get 5 plus 2, which is 7. 5 plus 2. On the right-hand side, you get 5 plus 1. 7, is that equal to 6? Absolutely not. Now, you can take any real value for x, -3, -2/3, negative 0.11111, and you put it on the left-hand side and the right-hand side, and you'll never get a true statement. And that tells you that this particular solution does not exist. There is no solution. So we can have a finite number of solutions, we can have no solutions, and then on the other end, number 3, we can have an infinite number of solutions, unlimited number of answers. Look at this equation. Think of a number. Your number that you're thinking is not the same as your colleague who may be sitting 2 or 3 kilometers away or in another town. I can take x. If I take x equal to 1, on both sides, I get 1 plus 5 is 6. 1 plus 5 is 6. Hey, 1 works. What about -3? -3 plus 5, -3 plus 5, it also works. In other words, irrespective of what number you take in this equation, this is an identity which is therefore true for any real value. So yeah, I would say x is an element of the set of real values. In this case, I would say x is an element of the empty set, and you can write it in braces like that. That would be the empty set. I'm just trying to bring set notation as well. In this case, A, if you just go back to A over here, we have only one solution, so we can say x is equal to 6, the set that only contains 6. So what I'm doing here initially as well is trying to recall how you write set notation in case you come across your readings in textbooks. So these are the basic types that you can come across. You can have a unique solution, no solution, or an infinite number of solutions. So let's go through some examples, and I'm going to run through these very quickly because you are quite familiar with this. So in my solutions, number 1, solve for x. 4 minus 3x is equal to 2x minus 11, and you can decide what to do. You can bring all the x's on the left-hand side, take all the x's on the right-hand side. Well, generally, people tend to take the x's to the left-hand side, or the variable to the left-hand side, and the constants to the right-hand side. Apply your addition of like term laws and rules, minus 3x, minus 2x, minus 5x, minus 5. Oh, sorry, there's a mistake, of course. Thank you. Did someone point that out to me? Well, whatever it was, thank you very much. I'll get to know your names, or if I ever get to know your names. Apologies. Minus 4 minus 11, that gives you minus 15. Then you can divide both sides by minus 5. Minus 15 over minus 5 gives you the answer x equal to 3. You can substitute into the original equation. 3 times 3 is 9, 4 minus 9, that gives you minus 5. 2 times 3 is 6, 6 minus 11 satisfies the original equation. What about number 2? I got 4 here, you're solving for a. 2a minus 3 minus 2 times a minus 4 is equal to 3 times a minus 3 minus 1. We're going to multiply and distribute into the brackets. So I'm going to get 8a minus 12 minus 2a plus 8 is equal to 3a minus 9 minus 1. Transpose all the a's on the left-hand side, making sure your signs are going to change if you are transposing. Minus 9 minus 1 plus the 12 minus the 8. 8 minus 2, that's 6 minus 3. That gives you 3a. Minus 9 minus 1 minus 10 plus 12, 2 minus, and that's minus 6. A is equal to minus 6 divided by 3 gives you minus 2. Straightforward examples. Let's go to the next one. Number 1 in this case. Just apologies with the numbering. They're not like in this slide. I have number 1 and 2. The next slide, number 1 and 2. Well, it doesn't really matter. So we are going to solve here. For number 1, our solution, 3 over x minus 2 is equal to 4 over 3x plus 4. Now, immediately, I want to, or let's do that last, simply because people just get into a procedure, which many people, of course, do. So you identify the LCD, there's nothing to factorize in the denominators, multiply by my LCD, x minus 2, 3x plus 4. Okay, I know my writing may not be the best, but what do you do? Unfortunately, I put a highlighter. You get used to it. So the x minus 2 times 3x plus 4. So I'll get 3, the x minus 2 cancels, times. So we remove the denominators of the fractions by multiplying through by the LCD. 4 times x minus 2, removing the brackets. That's 9x plus 12 is equal to 4x minus 8. And just going to cut down on some steps. Minus 20, I get x is equal to 4. So there is your solution. What about number 2? Here we are solving, and I'm going to do number 2 up here. 2x cubed minus 11x squared plus 18x minus 8. Oh, apologies. That should be equal to 0. So let me put that. That should be equal to 0. Now, let's have a look at this. Oh, you're quite familiar with this. You did this at school. In your calculus, you came across cubic function graphs. What did you do? You used the factor theorem. Did you say factor theorem? I'm not sure. But what do you actually do? You substitute. What values? Plus or minus 1, plus or minus 2, and so on, until you get 0. So in this case, 2x cubed minus 11x squared plus 18x minus 8, 1 doesn't work, minus 1, plus 2 works. So f of 2 gives me 0. Therefore, the sign change, x minus 2, is a factor. Now, how do you find the other factors? Now, I know there's different ways that you did it at school. You did synthetic. Some of you did synthetic, which I'm going to do. You could do long division as what we did now in the previous lecture. And then equating coefficients. Now, what do I mean by that? I'm not going to do it, but remember you did this, x minus 2, and then you did that with the x squared, and you used either k or whatever, and you worked it out and eventually got your answers over there. So I'm going to use synthetic. Why can I use it? Because my divisor is linear, and I'm just going to go through the process quickly, and I want you to do it yourself as well, to check that you get the same answer, whichever way you want to do it. So my synthetic division down there, across here, let me make it that straight. Vertical line on the left, I'm going to put 2. On the right, let me see, are they in decreasing powers? Yes. Is any power left out? No. So that's 2 minus 11, 18 minus 8. What is your first step? Bring down the 2. 2 plus 0, 2, multiply, put it under the next. 2 times 2 is 4, minus 7, minus 14, that's 4, and 8, voila. There you go. Therefore, 2x cubed minus 11x squared plus 18x minus 8 equal to 0 can be factorized to x minus 2, and then the trinomial x squared and x, there's your 3 values. 2x squared minus 7x plus 4 equal to 0. That factor is equal to 0. X is equal to 0. What do we do in this case? Think carefully. Can that be factorized? Look at it very carefully. I know some people will do something like this. 2x minus 1, x minus 4, and you get 2x squared minus 8x plus, that will be plus 1, then I get minus 7x, which is right. But look at the last term. That's a negative. And what's that? Positive. So this is an incorrect factorization. Therefore, what must you use? The quadratic formula. What's the formula? Yeah, you got no data sheet now. Don't go look for your data sheets. Come on, wrap it off. Minus b plus or minus square root of b squared minus 4ac divided by 2a. Hey, I don't know, I can't sing. Substitute, work it out. I want you to check this and verify. Correct to 3 decimal places. I get 0.719 or 2.781. Right, that is your equations. Now what we're going to do very quickly is apply those processes of the solution of equations to simple formulae. So for example, in the first one, solve for t if the square root of t plus 3 divided by the square root of t is equal to 2. So in my solutions, It's just various algebraic manipulations that we have to introduce. So I have the square root of t plus 3 divided by the square root of t is equal to 3. I just want to quickly go back to a very important point which I initially said I'll do first and then left it. In this particular case, number 1, I have the answer x equal to 4. Now, do I accept that answer, or are there values that this particular equation cannot take? Absolutely. The denominator, there are two denominators, x minus 2 and 3x plus 4, and they cannot be equal to 0. In other words, x cannot be equal to 2 if I do simple transposition. 3x plus 4 cannot be equal to 0. Transpose x cannot be equal to minus 4 divided by 3. And why must I check that? Because when I have a fraction, for example, a over b, remember that b cannot be equal to 0 because it makes it undefined. So I'm going to use the term undefined when we have denominators, fractions. Now, in our case, we got an answer x equal to 4, which does not correspond to any of those 2 and minus 4 over 3, which we have to reject. So in this case, we accept x equal to 4. But please recall, whenever you get fractions, check whether the denominators coincide with your answer. Right, let's get back to what we were doing here. So in this case as well, my denominator, which is the square root of t, must not be equal to 0. Square both sides, t cannot be equal to 0. Okay, does that impact the process and the procedure? No. We'll wait until we've completed and get the final answer and then check it with the restriction. So that denominator is my restriction. Okay, so what can we do here? We can multiply by the LCD. Square root of t plus 3 is equal to, again guys, why didn't you let me know? Okay, that was a 2. So this will be 2 times the square root of t. And there I have 3 is equal to square root of t. Then square both sides to eliminate the square root. And I get t is equal to 9. Now, I just want to pause here. Where did I get square root of t from? I know many or some students will be thinking, oh, square root sign, let's square both sides. But remember this left-hand side over here, only the square root of t has a square root. 3 does not have a square root. But then notice that square root of t is on both sides. It's like an x. Imagine that was an x. What would you do with the x? You would transpose it. So that's exactly what I did. So the step that I left out over here was transposing that square root of t. So I would be left with 3 on the left-hand side, 2 square root of t minus the square root of t. And that's saying there's 2 square root of t's. There's 1 square root of t. 2 minus 1 gives me square root of t. And that's where I get the answer that you see, that step that you see over there. So lastly, t equal to 9, do I accept? Does it correspond to the restriction? Not at all. Therefore, t equal to 9 is a solution. Let's do number 2. V is equal to U plus Ft divided by M. I want to transpose the formula so that I find F in terms of all the other variables. Now, once again, how you do that, just dependent on you. Really just depends on you. Firstly, I would go with LCDs. Let's remove the LCD, which is M. So every term multiplied by M, I'm going to get MV is equal to MU plus FT. It cancels out over there. And yeah, again, because F is positive on the right-hand side, I'm actually going to leave it on the right-hand side and transpose MU. And then how do I find F? Simply divide by T, so that I get F is equal to MV minus MU divided by T. Generally, we can leave it like that, but because this is in the physics, they tend to take the common factors out. There you go. Solve for F. So F is equal to M times V minus U divided by T. One more example, transpose the formula D, capital D over small d, equal to the square root of F plus P over F minus P. So we must find P in terms of F, D, small d, and capital D. Okay, in my solution, we got D over D is equal to the square root F plus P divided by F minus P. The square root is obviously the first algebraic manipulation that we have to eliminate. And the inverse operation is squaring. So you're going to square both sides, which is D over D squared. And although it's not necessary, I will show this. Square both sides. So on the left-hand side, I get D squared, small d squared. The square root and the square cancels off. I'm left with F plus P over F minus P. Now, aren't you tempted? Look at the P's. Do it. No, of course you can't. Can you cancel those P's? Not at all. If you can cancel a P's, that means you can cancel the F's as well. And then the F's disappear. So be careful, guys. Do not be tempted. Because as the eye falls onto a sum, it's like you isolate the P's only. But you can't, because there is a long division sign. You should actually put brackets around there. And that's where the LCD. And in this case, I'm going to do the quick procedure of cross multiplication. And it's only possible in this case. When do I do cross multiplication? When there's one term on the left-hand side, one term on the right-hand side. Then the denominator of the one can cross to the numerator of the other, and likewise on the other side. Or you can do it the long way by multiplying by your LCD, which I'm not going to indicate. But now let's see. We want to find F, and F is in the brackets. So I'm going to have to remove the brackets. D squared, distribute D squared into the brackets. Small d squared into the brackets on the right-hand side. And I want those terms that contain P to remain on the one side. So let's do this. There's minus d squared P. Transpose the small d squared P. That means d squared F must be transposed. And to make that positive, I'm going to multiply by -1. So I did d squared p plus small d squared p. This is going to change sign, d squared f minus small d squared f. Remove p as a common factor. And here I can remove f as a common factor. And there you go. P is equal to f d squared minus d squared over d squared plus d squared. That brings this lecture to an end. You can replay this, you can stop it, you can look at it, you can analyze it, you can do it for yourself, and hopefully you will get everything correct. Thank you.